All right, for our next item that we're going to look at, we're going to look at some trapezoids. So a trapezoid is a quadrilateral. Remember, a quadrilateral is a four-sided figure with at least one pair of parallel sides. So for example, we could have something like this, where these two are parallel. That's just a regular trapezoid. It's a four-sided figure with one pair of opposite sides that are parallel. An isosceles trapezoid is a little bit different. So an isosceles trapezoid is going to look more like this. Sometimes those lines can go inward, where we have one pair of opposite sides that are still parallel, because that's our definition of a trapezoid. But the isosceles part means that the side of the legs that are not parallel are also congruent. Okay, so you have one pair of opposite sides that are parallel and the other two are congruent. There are specific qualities or properties of an isosceles trapezoid. So these next three bullet points are going to go over these theorems, and then that's going to be the majority of your work, is really understanding how to apply those theorems to problems. Okay, so if it's an isosceles trapezoid, then each pair of base angles are congruent. So here's my isosceles trapezoid. Right off the bat, one pair is parallel and the other sides are congruent. And the base angles are the ones in the bottom. So they have to be congruent, each pair of them. So the base angles would be here, and this would also be the base angles. Anytime you're talking about the base is always referring to the parallel side. That's one thing that can be a little bit confusing, because sometimes they'll write your isosceles this way. Well, these are still the parallel lines, right? So this is still considered my base. So wherever the base is, the base comes from the parallel sides. All right, the next one, if a trapezoid has one pair of congruent base angles, then it's an isosceles trapezoid. Okay, so even if they only have one pair. And then lastly, if a trapezoid is an isosceles, IFF is short for if and only if. You'll see that a lot in upcoming math classes. So a trapezoid is isosceles if and only if its diagonals are congruent. So now we have diagonals here, and the entire line, it's not saying anything about them bisecting or anything, it's just saying the entire line is going to be congruent to each other. So let's go ahead and see how this looks with some problems here. So we're told that ABCD is just a trapezoid, but in looking at it, I know it's an isosceles trapezoid because I have two sides that are congruent and the opposite pair of sides are parallel. So it's got to be an isosceles trapezoid. I know that AC is 13.2, right? And I know that only BE from here to here is 8.4. Find DE. Well, with an isosceles trapezoid, I just went over the definition that the diagonals are congruent. So basically, AC is congruent to BD because those are the diagonals. Well, AC is 13.2, and BD, I don't know yet, but I do know that BD is a sum of BE plus ED, right? If I added those two pieces of the line segment together by segment addition that we haven't done in a while, but if I added those two together, it would give me the entire line of BD. And I know that BE equals 8.4. And so now I can find ED by subtracting 8.4 on both sides. So we get 8.4, 4.8, sorry. Okay, so ED is 4.8. Actually, I need to write it how they have it. So ED or DE, those mean the same thing. So I'm just going to switch it there. And DE equals 4.8 is the correct answer. And again, the whole purpose for me doing that is because the theorem tells me that the diagonals are congruent. Okay, next one. Find the value of x so that the trapezoid EFGH is isosceles. So you'll notice we don't have the congruent line segments here, but we're trying to make sure that we prove that they are going to be an isosceles. So in order for that to be true, then my base angles need to be congruent, right? So you'll notice my parallel parts tells me my base, and I'm just going to go ahead and set both of those equal to each other and solve for x. Now let's see how we are on this. Let's go ahead and move our 2x squared over to the other side. And then add 4 to both sides. And then I want to get x by itself, so I would have to square root both sides, right, you guys? And the square root of 25 is going to give me 5. I'm going to reread the question and see what it's asking for. It says find the value of x. And basically, I just found the value of x.